a grade 12 student from Pililia National High School. And the topic that we're going to discuss today is about continuity at a point. Continuity of a function. A function is continuous when its graph is a single, unbroken curve that you could draw without lifting up your pen from the paper. There are two continuities, continuity at a point and continuity on an interval. Continuity at a point. For a function to be continuous at a point, it must be defined at that point, its limits must exist at the point, and the value of the function at that point must equal to the value of the limit at that point. Continuity on an interval. A function is said to be continuous on an interval when the function is defined at every point on that interval and undergoes no interruptions, no jumps, and no breaks. If some function satisfies this criteria from x is equal to a and x is equal to b, for example, we say that f of x is continuous on an interval, close interval a, comma, close interval b. But our topic is focused on continuity at a point. Now, let's discuss more about it. Continuity at a point. Balikan natin yung definition kanina. Let's have an example. Consider the graph. Is the function continuous at x equal to 1? We can easily identify a function whether it is continuous or not because of the dot in the graph. A whole dot represents continuity at its point. Therefore, it is continuous. Tingnan naman natin ang pangalawang graph. A dot with a hole represents discontinuity. Therefore, it is discontinuous at x equal to 1. Paano naman kung walang graph? Masasabi kaya nating madali lang mag-solve ng isang function kung walang graph? Function is continuous at the point x equal to c if the following three conditions are met. 1. F of c is defined. 2. The limit of f of x as x approaches c exists. And 3. F of c is equal to the limit of f of x as x approaches c. If at least of this condition is not met, the function is said to be discontinuous at x equal to c. Example 1. Determine if f of x equal 5x squared minus 6x plus 1 is continuous or not at x equal to 2. First condition, f of c is defined. In finding the f of c of the function, substitute the given value of x, which is 2. F of c is equal to 5x squared minus 6x plus 1. Then substitute the given value. F of 2 is equal to 5 times 2 squared minus 6 times 2 plus 1. F of 2 is equal to 5 times 4 minus 12 plus 1 is equal to 20 minus 12 is 8 plus 1, 9. Therefore, f of c is defined. Second condition, limit of x as x approaches c must exist. In finding the limit of f of x, substitute 2 where the x approaches and simplify the function. The limit of f of x as x approaches 2 is equal to 5 times 2 squared minus 6 times 2 plus 1 is equal to 5 times 4 minus 12 plus 1 equal to 20 minus 12 is 8 plus 1, 9. Therefore, the limit of f of x as x approaches 2 exist. Third condition, f of c must be equal to the limit of f of x as x approaches c. F of 2 is equal to 9, equal to the limit of f of x as x approaches 2 is 9 also. Therefore, f of x of 5x squared minus 6x plus 1 is continuous at x equal to 2. Example number 2. Determine if f of x equal to 2x minus 4 over 3x minus 3 is continuous or not at x equal to 3. First condition, f of c is defined. F of c is equal to 2x minus 4 over 3x minus 3. F of 3 is equal to 2 times 3 minus 4 over 3 times 3 equal to 3. F of 3 is equal to 6 minus 4 over 6 minus 3 equal to 2 over 6 or 1 over 3. Second condition, limit of f of x as x approaches c must exist. Limit of 2x minus 4 over 3x minus 3 as x approaches the 3 is equal to 2 times 3 minus 4 over 3 times 3 minus 3 equal to 6 minus 4 is over 6 minus 3 is equal to 2 over 6 or 1/3. Therefore, limit of f of x as x approaches c exists. Third condition, f of c must be equal to the limit of f of x as x approaches c. F of 3 is equal to 1/3, and the limit of f of x as x approaches 3 is 1/3 too. Therefore, f of x that is equal to 2x minus 4 over 3x minus 3 is continuous at x equal to 3. Number 3. Determine if f of x equal to 2x minus 4 over 3x minus 3 is continuous or not at x equal to 1. First condition, f of c is defined. F of c equal to 2x minus 4 over 3x minus 3. Substitute 1 from c. F of 1 is equal to 2 times 1 minus 4 over 3 times 1 minus 3. F of 1 is equal to 2 minus 4 over 3 minus 3 equal to negative 2 over 0. Therefore, f of c is undefined. The first condition is not satisfied. Therefore, f of x equal 2x minus 4 over 3x minus 3 is discontinuous at x equal to 1. Example number 4. Determine if f of x plus 1, if x is less than 4, and x minus 4 quantity squared plus 3 if x is greater than or equal to 4 is continuous or not at x equal to 4. Finding f of c in piecewise function, we should get the function where x is equal to 4, and that is quantity of x minus 4 quantity squared plus 3. Calculating the limits of a piecewise function, we should calculate separately the limit of the left side and the right side of the equation. Get x equal to 1 where x is less than 4 for the left side. Then get the quantity of x minus 4 quantity squared plus 3 where x is greater than 4 for the right side. Limit of x plus 1 as x approaches to the left side of 4 is 4 plus 1 is equal to 5. While the limit of quantity x minus 4 quantity squared plus 3 as x approaches 4 to the right side is 3. Therefore, f of x plus 1 where x is less than 4 and x minus 4 quantity squared plus 3, where x is greater than or less than 4 is discontinuous at x equal to 4.